This is the finished and working successive approximation register analog to digital converter, or SAR ADC design, created by Mitsuru Yamada. A link to his original design can be found in the description of this video. It takes in an analog voltage, which comes from this potentiometer, in this case, but could be any analog input from a joystick to a microphone to anything else, and outputs a 7-bit digital signal that is the best possible approximation of that voltage. The purpose of an ADC is for analog devices like a mouse to interface with digital devices like a computer. As you can see here, as I turn the dial towards 5 volts, the binary output gets closer to 127. And as I turn it the other way, it gets closer to 0. So 0 all the way to 127 and back to 0. Here's the schematic of the SAR ADC, which I like to think of as a loop of 2 main sections, as well as a timing section and the output section. The timing section consists of the clock and what I like to call the timing register. On the board, that's this bit here. The clock is a 10 kilohertz inverter clock, which uses the fact that NOT gates always output the inverse of their input to create a feedback loop, whose timing is controlled by resistor-capacitor circuits. This feeds into the timing register here, whose inputs are each tied to the previous output. The exceptions to this are the first input, which is tied permanently to 5 volts, and the last output, which produces the reset signal in automatic mode. This means that each tick of the clock, one more of the register's outputs will go high in sequence until it is reset. The first section of the loop consists of the successive latches and the DAC, and that's this whole section here. That's most of the bulk of the design on this board. The successive latches here each take input from the comparator output, which is the third section, and they're each clocked by an output of the timing register in sequence. They all begin with a 1 preset into them and are ANDed up here with the previous latch's clock before being passed into the DAC over here, each with a respective bit value. This DAC, which is an R2R DAC, which I won't go into as I've already done a project building an R2R DAC, converts the output of these AND gates to an analog signal. And the latch's outputs are also sent to the output section over here. So the second section is the comparator, and that's this tiny section over here. This section has the analog input, which is the potentiometer, and a sample and hold integrated circuit that samples the analog signal once at the start of the approximation and holds it until it's told to sample again. This ensures that the input voltage does not change mid-approximation, which could lead to improper approximations. An op-amp, which is this, compares this signal with the DACs, which produces a signal that is fed back into the latches. And that's this wire here, feeds it back into the latches. So how does this whole system approximate the voltage? Well, to see that, let's follow one cycle through the ADC. The DAC begins with a 1 in its MSB input and zeros in all the rest. This means that it's cutting its available voltage range exactly in half because the MSB is on and the rest of the bits are off, which is exactly half of the highest possible binary value. This is compared with the input, and depending on if it's higher or lower, the first latch will be locked in as a 1 or 0. As this is clocked into the first latch, the second AND gate also outputs a 1. This means that whether it was higher or lower the first time, the range has now been cut in half again, and this repeats with less and less significant bits until the approximation is finished. Then, the last latch resets the sample and hold up here, presets the latches to 1 again over here, and clears the timing latch here, but only if the SAR ADC is in automatic mode. If it's instead in manual mode, it will wait for a low signal on the clear pin of the timing register to reset the system. So let me show you the difference. Here's automatic mode, where as I turn the dial, it will automatically recalculate. And here's manual mode, where I have to use this button to recalculate. So if I turn the dial, I don't see anything, but then when I push the button, I get my measurement out, and I can keep doing that with different measurements.